Hello everyone, in this lecture we will discuss about what is difference between AWS Transit Gateway and VPC peering. So let's get started with the video. So first of all, I am giving an introduction of VPC peering. So VPC peering connection is a networking connection between two VPCs that enable you to route traffic between them using private IPv4 addresses or IPv6 addresses. Instances in either VPC can communicate with each other as if they are within the same network. You can create a VPC peering connection between your own VPCs or with the VPC in another AWS account. So the VPCs can be in different regions also, as known as an interregion VPCs peering connection. So AWS uses the existing infrastructure of a VPC to create a VPC peering connection. It is neither a gateway or nor a VPN connection, or does not rely on a separate piece of physical hardware. There is no single point of failure for communication or a bandwidth bottleneck. So in VPC peering, there is a network connection between two VPCs. So a VPC peering connection help you to facilitate the transfer of data. For example, if you have more than one AWS account, you can pair the VPC's connection, those accounts, to create a file sharing network. So you can also use VPC peering connection to allow other VPCs to access resource you have in one of your VPCs. So next, there is a two VPCs could be in the same or a different AWS account. Two VPCs could be same or different AWS account. It should the two VPCs account should be same or different, so it can communicate with each other. Now low cost, since you need to pay only for data transfer, so the cost is also so low. Next, there is no any bandwidth limitations and no transit routing, and complex at scale, and minimum 125 connections per VPC. So next, there is a no transit gateway. How it works? So let's get started. So let me see. So to understand the concept of no transit routing, we will take three VPCs, that is VPC A, VPC B and VPC C. Let's suppose we have a VPC peering connection between VPC A and VPC B, and another between VPC B and VPC C. There is no VPC peering connection, and transitive peering, and between VPC A and VPC C. This means we cannot communicate directly from VPC A to VPC C. So through VPC B and vice versa. Due to this lack of transitive peering in VPC peering, AWS introduced concept of AWS Transit Gateway and transit gateway, no transit routing. To understand the concept of no transit routing, we will take three VPCs like VPC A, VPC B and VPC C, as you can see. So let's suppose we have a VPC peering connection between VPC A and VPC B. So we are making a peering connection between VPC A and VPC B, let's suppose. So and another connection between VPC B and VPC C as well. So there is no VPC peering connection and transitive peering and between VPC A and VPC C. So this means we cannot communicate directly from VPC A to VPC C. Through VPC B and vice versa, you can communicate but not directly. So due to this lack of transitive peering in VPC peering, so AWS introduced concept of AWS Transit Gateway. So let's get discuss transit gateway. So the transit gateway is a network transit hub that you can use to interconnect your virtual private cloud VPCs and on-premises networks. So as your cloud infrastructure expands globally, interregion peering connects transit gateways together using the AWS global infrastructure. So AWS Transit Gateway is a fully managed service that connects VPCs and on-premises networks through a central hub within a railing or numerous point-to-point connection or transit VPC. So using Transit Gateway, you can manage multiple connection very easily. You can connect with the multiple connections. So AWS manages the auto scaling and availability needs. So it also manages your auto scaling and your availability needs, and supported thousands of connections. And there is an extra hourly charges per attachments, and in addition to data fee, so which makes transit gateway configuration costly. And next, maximum bandwidth burst to 50 gbps. Maximum bandwidth burst to 50 gbps, and transit gateway pairing only possible across regions and not within region, and it possible across region. And hub and spoke network topology for connection VPC together. So as you can see in this picture, hub and spoke design VPC, there is a 3 VPCs with the single transit gateway attachments. You can attach in a single transit gateway attachment, you can attach your VPCs, and there's a transit gateway, and through which you can your VPC direct connect, and this is a corporate data center. And so the transit gateway enables customers to connect thousands of VPCs. You can attach all your hybrid connectivity VPN and directly communicate to a single transit gateway and instance, and controlling your organization entire AWS routing configuration in one place. And transit gateway control how traffic is routing among all connected spoke networks using route table. So this hub and spoke model specifies management and reduce operational cost, because VPC only connect to the transit gateway instance, and to gain access to the connected network. So the transit gateway is a regional resource and can connect thousands of VPCs within a same AWS region. You can create multiple transit gateway instance per region, and you can connect to a maximum of 3 transit gateway instance over a single direct connection for hybrid connectivity. So typically you can use just one transit gateway instance in a given region, and use transit gateway routing table to associate them wherever needed. And there is a valid case of creating multiple transit gateway instance to limit and misconfiguration, blast radius, segregate control plan operations, and administrative ease of use. So with transit gateway pairing, customer can pair their transit gateway instances within same or multiple region and route traffic between them if uses the same underlying infrastructure as VPC pairing, and is therefore encrypted. So the transit gateways across different regions can pair with each other to enable VPC communications across regions. Each spoke VPC only needs to connect to the transit gateway to gain access to other connected VPCs, provide simpler VPC to VPC communication management over VPC pairing with a large number of VPCs. Transit gateways also allows for more VPC per region compared to VPC pairing, and better visibility, network manager, cloud watch metrics, and flow logs compared to VPC pairing. Also, transit gateway route tables per attachment allow fine grained routing. The complexity is based on region count, and that's all in this video. Hope you will like it, and thanks for watching.